So what is actually track 3 is a non-traditional practice of design and constructing the POW, but it's included here as you may need it for a special reason on purpose that we require to require the retap. Right? We plan to retap the POW no matter what. Whether we achieve that capacity or what, but we will retap the POW to verify the POW capacity. For good reason that you want to have a better comfort of the gain in capacity. You want to investigate that scenario and the condition. That's what is covered in the track 3. As well as in track 3, there's another example show how you could use PDA and CAD-web as a construction control. I know that PDA and CAD-web is not commonly used, but but we included that as in the track 3 example. So what you're going to learn from this presentation is, again, the design and the construction steps, resistance factor selection, determine the target driving resistance, but based on the required planned retaps. So up to the previous presentation, we say that retap is required only when you need it. Only when the performance is not met, we retap the POW. But in this track, we say that we're going to plan the retap. Right? We plan for it. So example, track 3, example 2, integrate abutment, steel edge POW, cohesive soil, with planned retap is the construction control procedure. So in this situation plan, you have 240 feet span length, 0 scale, integrate abutment. All right, a nice cut of cross section. Because the span length is more than 130 feet, we will have 10 feet of brief boreholes. Elevation of 435, and the soil profile is 3 feet of topsoil, 27 feet of firm glacier clay, and the remaining 50 feet is a very firm glacier clay. So primarily this POW is embedded in a cohesive soil profile, but we will have to verify that for academic and for that good reason. Recommendation of the foundation, friction POW, tip up in very firm glacier clay, normal driving resistance, structure resistance level number 1, no special site considerations for stability, settlement, or lateral movement. Again, the same as you have in the track 1, 9 POWs as a group, 10 by 57. Factor load is 128.6. No uplift, down drag, or scour is considered. But the difference here is that you have a construction control using whip with 3-day planned retap. Right? You plan to retap the POW 3 days after the end of driving. No need for lateral load or special consideration. Again, this is the table to determine the geotechnical resistance from using the Iowa Blue Book method. You have the thickness of the soil, but then because of the 10 feet brief borehole, the resistance is not considered in the layer 1 and layer 2A. Right? So you start with this firm glacier clay, thickness of 20 feet, N value 11, 2.8 as your unit skin friction, and 56 is your total friction. And down to layer, should be 3 here, very firm glacier clay, 50 feet, N value is 25, 4 is the unit friction, and the accumulated site friction up to this depth is 256 kips. And you do have N bearing as the N value is greater than 20. You do have an N bearing of 2 KSI that you select from the Iowa design chart. Right? So now is what resistance factors should I use from this table for design? Right? we say that we're going to use WIP as a construction control. We plan to retap at 3 days, right? But for the xi, there's no specific number that require whether you require retap or no retap, but the same resistance factors will be used depending on the soil type, right? So WIP as construction control, following along this row, these are the resistance factors, right? But if you were to use PDA and CAPWEB together with WIP as construction control, all right, and you have planned retap at 3 days, yes, 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 then that's the difference in the resistance factors, but not in the WIP alone, right? So because of you have multiple tests and you plan to have retap, obviously you gain more confidence. With that reason, the resistance factors increase. Up to a point, we set it the maximum of 0.8, which is consistent with what the AASHTO recommend in the LRTF specification, right? So this is a cohesive material, so the 0.65 will be selected. Again, this is a factor load divided by 0.65, and this is your required nominal power resistance to determine your contract length, 197.8 kilograms per pound, right? Again, the same procedure, determine the friction along the depth and determine the required length. And the required length, including the end bearing, is 57.1 feet. Plus the 2 feet of embedment, plus 1 feet of cutoff, total contract length is required is 60.1, and we'll say 60 feet as our contract length, right? Now, we need resistance factors for construction control, right? So if you look at this table, resistance factors for construction control, you want me to conclude my presentation as quickly as possible. So let's continue. All right, we have WIP as our construction control. Now you see that there's a yes here under the retap 3 days after end of driving. Okay, so we say that the resistance factors should be 0.7 if it's a cohesive materials, 0.65 for mixed, and 0.55 for non-cohesive, right? So you may ask, how about if I do a retap, plan the retap at 4 days? But this table shows that I have retap test 3 days after end of driving. So should I use the same resistance factors? The answer is yes, right? So you plan to do the retap, and that is the resistance factors. If you plan to retap it at 7 days, 3 days, 4 days, whatever days, that is the resistance factors to be used. 0.7 if it's cohesive materials, all right? Okay, there's a correction on this slide. I will explain that. So the fee is 0.7 for cohesive soil with retap test 3 days after end of driving, as well as 7-day retap. Right? The rate one should be an addition of what you have on the slide, on the worksheet. And why I say 7 days, but all the while, we consider the setup or gain in resistance up to 7 days. We want to take advantage of the setup up to 7 days. Right? Although we retap in 3 days, but we want to make a maximum up to 7 days. So we've determined the nominal geotechnical bearing resistance based on a setup of 7 days. Okay? So you take the load divided by this fee factor, 0.7, and that will be your required 183.7 kips at 7 days. That is your target driving resistance at 7 days. Okay? But we always compare the performance at the end of driving. We cannot wait until 7 days. Right? So we take this number, back calculate to the end of driving as what is described in track 1, right? To determine the REOD. So this is what is required at 7 days. We know that the average, weighted average of N value is 19. So from this design chart, right, 7 days, the factor is 1.57. All right? So we take the capacity required at 7 days divided by these factors. That gives us the required capacity at the end of driving. We require it at 7 days, but we back calculate to the end of driving capacity. Okay? So what is actually required to verify the performance at the end of driving is this, 59 tons. Okay? So the remaining capacity will be taken care or accounted for by the setup up to 7 days. Now the question is, what will be the driving resistance required at the retap 3 days? Will it be the same, 59 tons? Will it be the same? This is at end of driving. But 3 days you had gained quite a number of amount of setup, capacity. So we got to calculate the target driving resistance at 3 days, right? So we know that what the factors is 1.52 at 3 days. So we take this number and multiply to the REOD that we calculate from here. That is what is required at end of driving. We multiply by this F setup, 1.52 from this chart, based on the 3-day line. And that gives us the target driving resistance at 3 days. Let's look back the numbers, right? Let's look back the numbers. This is 7 days, 183.7, okay? This is 117 at end of driving, 177.8 at 3 days. You see the trend, right? Smaller at end of driving, increased up to this value at 3 days, and then increase up to 183.7 at 7 days. Okay? So if you were to verify the power performance at end of driving, and this is the number will be used, 117 and or 59 tons. Because you plan to retap the power, and you will have to compare with this target driving resistance at 3 days, which is 177.8 or 89 tons. All right? So the design note basically is to summarize the information of the load, the geotechnical resistance from Blue Book, the resistance factors used, and to specify the type of construction control. In this case is WIP from a corrosive soil classification and a resistance factors of 0.7. That is based on the retap of 3 days that the selected resistance factors is 0.7. And driving notes, 59 tons at end of driving. If you plan to retap, you see the must be retap. You see the driving notes? The pulse must be retapped because you specify that you require retap. At 3 days with a required nominal axial bearing capacity of 89 tons. It's not 59, but 89 tons. Because of the setup, the contract length shall be driven as per plan unless pulse reach refusal. Construction control requires a WIP analysis, bearing graph, and retap at 3 days 3 days after end of driving. All right? So you do the independent jack before the final plans are produced. Contractor provide you the hammer information. You run the whip analysis, generate the bearing graph. Here's the bearing graph based on the 3 different strokes. And you record the hammer stroke, you record the hammer blows, and you determine the driving resistance from the bearing graph and compare with your target driving resistance at end of driving, which is 59 tons. Right? And then you do a retap. Right? You do a retap at 3 days. Again, you have the hammer stroke. Again, you have the blow count during the retap at 3 days, and read off from the bearing graph, and then compare with that target driving resistance of 89 tons at 3 days. Right? So summarize the outcome of the example 2. Again, to remind you that nominal resistance from Blue Book resistance factors based on depending on soil type and construction control. In this example, the contract power length is 60 feet. Construction control with 3-day planned retap. Resistance factors is 0.7. Target nominal driving resistance is 59 tons at end of driving. Setup factors is 1.52 at 3 days. That gives you 89 tons target driving resistance at 3 days. Right? Here's the outcomes of this presentation. Able to follow the steps, determine the right resistance factors, determine the contract length, the target driving resistance at end of driving, as well as at the 3-day retap.